Yeah, here we go. We're good to go.
Awesome, fantastic. So my name is Alex. This is the Front End Guild group, weekly, bi-weekly presentation thing. I said I was going to present about Rust on the front end, but I secretly lied, and this is mostly a presentation about WebAssembly. So the structure of this is going to be basically, I'll talk a bit about why WebAssembly. I'll show a bit of like a couple of random demos from around the internet of what WebAssembly is capable of. And then I'll do a little bit of just some minimal live coding demos, or minimal demos of live code, just to show folks that Rust in particular is a perfectly fine choice for targeting WebAssembly, deploying non-JavaScript languages to the browser, and that it doesn't look entirely alien, and it sort of is similar to the kinds of things you might see in React and other kinds, other parts of the JS ecosystem. Cool. So first of all, why WebAssembly, or what is it? Basically, ever since the web started in the World Wide Web, the internet in the early 90s, there's been a huge amount of interest from large corporations to deploy rich content to the web. And how do people do that? Well, HTML and CSS have been there since the beginning, since 1991 or whatever, and they have various precursors. JavaScript was part of the larger browser wars in the 90s, where a variety of large players were all trying to dominate the ecosystem and all trying to basically ship their own in-house version that was platform specific and vendor locked. Almost immediately you started getting things like rich media players to play games or video content or audio. You have things like Flash Player coming out in '96. You have Microsoft ActiveX that only worked on Windows stuff. You have Silverlight. All of these things have been since then deprecated and have died as the web, as the browser platform has grown to standardize more and more of those rich media APIs, which has been a trend over the past decade and more. But during that time, at that time in the late 90s, there was a lot of scramble to okay, maybe JavaScript is going to be a Microsoft only thing. Maybe it's going to be the kind of thing that's different in every browser. We want to ship lots of, we want to show you Blinky ads, very efficiently, lots and lots of Blinky ads. How do we do it? So that's the kind of background where the motivation for WebAssembly comes from. The idea that we can't, no one player wants the others to dominate the market. The 90s resolved themselves, the browser wars were fought and were lost and won by various parties. And standardization came underway. And we started getting more of a kind of consortium of multiple players, your Googles, Amazons, Apples, whatever's, trying to come together and devise efficient means of delivering rich content that JavaScript at the time, and possibly even to this day, was not very equipped to handle. So again, things like games, things like very rich in-browser applications. So for instance, the very recent Photoshop on the web, that's that kind of experience. So fast forward a little bit, and circa 2011, you get things like Google's native client, or NACL, N-A-C-L, which is a chemistry pun. Because the API for NACL is called Pepper, because you get it. So NACL was basically, what if we let you take your existing C and C++ applications and dump them directly into the browser somehow? We'll build a runnable runtime, we'll build a way to transpile the stuff and ship it to the browser. The issue with that is that it was A, very performant, but B, it was Google specific. Basically it only ran in Chrome and was kind of almost part and parcel of Chrome OS, ongoing mega effort. A couple of years down the line from there, around 2013, Mozilla came out with a competing effort, which they called ASM.js, which came from a slightly different direction of basically saying, what if we, instead of building an entirely separate runtime, we just identify a small piece of JS that is very restricted and very sandboxed, and then target that for optimization. Because of course, over time, since the 90s and into the 2000s and to this day, there have been lots and lots, millions of developer years poured into optimizing JavaScript runtimes, making them run faster than the thing people complained about in the 90s with very non-performant JavaScript runtimes. So they came out with ASM.js, which was much more portable because ultimately it was just JavaScript. It was like C++ compiling to a small subset of JavaScript, which was then further optimized in a just-in-time compilation sort of way. But that was not as performant as NACL. So you have these two approaches, one which is very performant but very platform specific, and also very vendor specific. And you have this other one which is much more portable, but also not nearly as performant. So circa 2015, so like these like 2-year jumps, a lot of the industries somehow came together, like Google, Apple, Figma, Adobe, other random people, and created a working group in the W3C, the World Wide Web Consortium, to put together a portable, performant format for binary applications in the browser, which became known as WebAssembly. What WebAssembly is primarily a standard. It's basically a binary API for like how to, like, it was a standard for like, what do you have to build for your product to be called a WebAssembly runtime? And all the browsers have since then implemented in-browser WebAssembly runtimes. So like, it's basically, you can write your program in whatever language. Like, I mean, ultimately this is like up to your company to build a platform and a pipeline for this. So like, let's say you write a program in C++, and then your compiler somehow targets WebAssembly by emitting bytecode in the right format, so that the browser, for instance, can then take the compiled code and run it as if it was native code. So as part of WebAssembly, you got this binary standard. You got a human readable format for like actually like writing programs in it by hand if you were somehow perverse enough to want to do that. And then also like an ongoing effort by the working group to build APIs so that WebAssembly, which is inherently designed to be very sandboxed, very small, very minimal, can then go on and in a modular, secure way access like native capabilities in the place where it's running. So like by itself, with nothing else enabled, WebAssembly has no notion of file systems. It has no notion of displays or monitors. It has no notion of anything. All these things have to be added on as like separate capabilities, which are enabled and disabled at your leisure. We can like briefly look at like what WebAssembly actually looks like, and then take a look at some demos of things people have shipped using it. So let's, oh, it's so bright. Anyway, WebAssembly, or WASM, or WASM, or maybe just choose whatever you want. Let me hit Command plus a couple times. There's a lot of like docs and a lot of like excitement about this stuff, so it's not difficult to find information about it. Anyway, here is, that's sort of visible, cool. So here's like a little sandbox for like what WebAssembly code looks like. Over here in the upper left, we have the human readable format, which looks a lot like a Lisp, if you like Lisp, which if you do, you're old. It turns into this binary output over here, blah, blah, blah. You can, like, once compiled, you can invoke this code from JavaScript. So over here, we make a new WebAssembly instance with the module which we have compiled. This module exports a function called add2, which just adds two numbers and emits their sum. And here's how we call it. So we grab our add2 function from the exports of this module, and then we just call it. So that's the essence of what WebAssembly is. It's just, it exposes a computation engine, which you can then access from JavaScript. In that sense, it's sort of like web workers or like other things where you can offload work to. And then over here, you have the output where like, yeah, some number of numbers is whatever. Let's just change this 4. There you go. So it's kind of live. All right, so what can you do? Like, what kinds of tomfoolery you can get up to with WebAssembly? Well, you can ship Python to the browser. Just literally Python, literally in the browser. Like, there's like some code examples over here. Here's some code in Python that fetches some endpoint. Here's FizzBuzz in the browser, everyone's favorite. Let's add some Z's. There's Z's. Python, why not? Here's Vim in the browser. Everyone likes Vim, right? It's just actual Vim. And you can like execute this code and it will sort of run. That's cool. You can have, like with extended capabilities, like file system and whatever else, you can have rich media support. So for instance, here is in browser audio and video transcoder, FFmpeg. So I can load some sample files. I can run the converter. And this is the actual FFmpeg you would have run like in your command line to like transcode your videos for YouTube or whatever. And then eventually it does stuff and you can download the output and, well, with output it doesn't matter. It's like a little video of like something. Let's see, what else do we have? Oh yeah, here's a fun one. Let me see if I can enable sound here. Hopefully it's not too loud. An interactive synthesizer. Let's see.
Let's go.
I don't actually know how synthesizers work, but look at that. And it's doing it live. It's like synthesizing the sound on the fly. You can ship ML models. So here's also music, but it's a TensorFlow drum machine where you like populate some things on these tracks. You set a nice high temperature to make it do all kinds of wacky. You generate, and there's your drum track for your next party. Amazing. Awesome. Like again, like WebAssembly doesn't write this stuff for you. It basically lets you write stuff in other languages and then dump it into the browser. So like TensorFlow is historically a Python/C sort of thing, but here's an application that would ship directly to the browser. Or if you have some like code from the early 90s lying around and you want to like port your, if you're like, id Software and you want to port your early 1990s games to the browser, you can just, you can play Commander Keen in the browser. Why not? Look at that, I have 14s left, and this is unmodified code from like the early 90s. And yeah, you can like your lollipops and shoot space aliens and yeah. This is what id Software worked on before Doom. But speaking of Doom, here's Doom running in the browser.
Okay, let me get this started.
This is Doom 3.
You're gonna need to hold still. Moving around only makes the test take longer.
Yeah, it's terrible.
All right, bioscan looks good. You're cleared for entry.
Excellent. And there's like brain crabs or whatever. No, it's like a droid.
On behalf of the UAC, welcome to Morrison. This facility serves...
Anyway, cool. Let's maybe kill the sound. Awesome. Anyway, so these are like things you can ship to the browser using WebAssembly. And of course, you have like your Adobe Photoshop on the web, you have your Google Earth, you have Figma's obvious example. A lot of the video conferencing stuff is run performantly using WebAssembly, that sort of stuff. So that's the kind of capabilities we are talking about here. All right, so now we've seen a lot of cool stuff. Let's look at things that are much less cool. Let's look at some code. And let's also, okay, where is my, let's quit time, why not? All right, let's look at some code. So how do you, like, as I mentioned, like one of the ways to target WebAssembly, like the thing that can emit WebAssembly code for you to ship to the browser is, well, C or C++, which are both old and janky and nobody likes them, except people who write performance software. But if you're new and cool and awesome and you want a language for nerds, there's Rust. Rust looks a lot like C, C++, or Java, or even other languages. And it has paid a lot of interest to, well, it knows that WebAssembly is hot. So there's a lot of interest in shipping Rust applications to the web using WebAssembly. So let's take a look at a couple of frameworks with just like a little, just a few code samples to see what it looks like to write this stuff and what like hello world applications might look like. Anyway, so let's do a very minimal hello world. All right, so over here we have a full stack application in WebAssembly written in Rust. It's a server and a client, and it ships a bundle to the front end, and all it does is it just says hello world. So let me just quickly build it and make sure that I'm not lying. And I'm in the right place, and here's build, build, build. Okay, fantastic. But that's not what I want. Where's Chromium? Well, I have the wrong build output. Anyway, sorry, this is what happens with live coding. Save, die. Well, if I can't figure out how to clean the cache, I'll just walk through the code examples, and you folks have to accept the fact that it's just hello world. That's, I think, probably enough. Okay, well, it still doesn't say that because I think I have something cached somewhere. That's fine. Anyway, well, hello world. So the interesting part of this particular thing is that you basically end up writing components. So in this case, app is a component. It's the root component of this application, and all it contains is a div. And then inside this div, you could add like style and stuff like that. So like this is just a div contains some text. That's fine. Let's close this out. Let's go here and uncomment a larger example. And I should learn how to hold down shift. Shift, shift, shift. Okay, where does it start? It starts over here. All right. Let's see. Die. I want this. And this should end up being a very minimal Hacker News UI if I can figure out what's going on. Oh, yeah, sure. I should comment out this other one first. All right. Build. Build. Error binding, listener already in use. Let's see, which port is this on? 80. Kill whatever's running over here, which is this thing. Let's rerun the build. And let's hope it actually does what I want it to do. Okay, cool. So this is hitting like a very small and slow Firebase instance, so it might take a second to load. So just getting a little warm here. All right. So this is a minimal, basically proxy to Hacker News. And as you hover over the stories, it just shows you a little preview on the right. I'm pretty sure it's live. I think these are like stories from today. In fact, somebody's getting very excited about Steelbank Common Lisp. Anyway, so, minimal application, very simple. Let's take finally, let's take a look at another one of these DSLs for shipping WebAssembly from Rust, which looks a little bit even more similar to JSX than this one. Let me see if I can remember where it is. Okay, here we go. Let's see. Counters. Let's take a look at a minimal example. So this previous example was in a framework called Dioxys. This next example is in a framework called Leptos, okay, let's take a look at this code sample over here. Anyway, okay, so in terms of what we're looking at, this is basically the front end where you have, what are we looking at? Oh, yes, this is the server part of the code. Very, very simple, very, very minimal. All it does is it just takes our component and it renders it to the body element. Cool. This is the stuff, this is the actual component itself. It just do counters. You can see that apart from the weirdness where you wrap this in this Rustism view macro, you're just writing basically HTML with listeners and values, and this looks a lot like JSX. And the listener itself is a function you define that does some increment on a value. So over here we see a create signal, which I think might be familiar from Wayne's presentation 2 weeks ago, where you have a reader and a writer. We print the value of the reader, and we increment the writer over here, where this is the set value that gets incremented. Let's take a second to run this. Sure. Run. I should have run this first. Sorry, just pulling a bunch of stuff. Pull, run. And then after this launches, we should see a very simple page with a counter, incrementer, and decrementer. All right, here we go. Actually, over here, just copy this address exactly. And let's go over here and just open an incognito window. Okay, cool. You can add counters. They increment and decrement. You can add 1,000 counters, and it's pretty performant. Like this is 1,000 pieces of like live data in this application. Okay, cool. Let's kill this one and let's look at just like one final example that shows a front end and a back end, just like some, like storing some basic data as SQLite. Let me see. Blah, blah, blah. Let's to do app SQLite. Fantastic. Okay, let's go to the start of this. Let's first run it and then like do a really, really quick dive through the code and then wrap up. Cargo make start, sure. Okay, fantastic. So here's the world's most minimal, tiny to-do application. It just basically takes a label from this or like input from this input box and creates a to-do for it on the back end. But the interesting part is that there is actually an artificial delay on the creation of each to-do. And as you can see, the purple ones are in flight. Like it optimistically renders the items which still haven't confirmed, which haven't been confirmed by the backend. Like this isn't necessarily very complicated or anything. It's just that this is built in natively. Like there's been some effort made here to make this ergonomic for developers coming from other languages. So if you're familiar with React or Solid or whatever it is, this will be like the on-ramp to WebAssembly, like web app stuff in Rust, is gentler than on-ramp for like to Rust from other languages for like more general purpose applications. Anyway, so yeah, you have a you have an add, you have a delete, blah blah blah. And let's just do a really, really fast code walkthrough and then wrap up here. Cool. So what are we looking at? Here is the server, like the Express part, or like whatever your Node.js or like your Next.js part would look like. We grab a DB connection. We grab a configuration file. We grab some stuff like our server address and port and whatever from this file. We create an HTTP server. We load the application into it, and then we run, and that's the back end, the end. This is the front end. This is the part that like does the hydration after the back end does the server-side rendering. The hydration is also very, very simple. It takes your application, which was our to-do app, it mounts it to the body element, and there's like just some like logging stuff over here. That's the extent of that code. The actual application lives in this third file over here, and this defines kind of like the API of like what is it to do, what does it shape, what are our server functions, how do we call into them. So like here is our data endpoint for getting the to-dos. We just load them from a database and then like do some formatting in the data. Here's the add, here's the delete, here's a component, and you can see that this looks a lot like JSX or HTML or whatever you want it to look like. Again, it's like wrapped in this Rustism over here. Rust is the distinction of having macros, which basically turn whatever you want into whatever else you want, and just kind of like runtime code generation. So this does turn into like a blob of code, but you can write it as if it wasn't there, just this kind of stuff. Here's like another component. Here is a massive soup of divs and things, because this is just demo code. But ultimately, all this does is just like show you a list of existing to-dos, and followed by a list of your in-flight to-dos. And this is wrapped in basically a suspense and yet another div, why not? So again, like this is code which shouldn't be unfamiliar. This is like very similar to the kinds of stuff you would have written to like load data, munge data, display data using React or any other framework. Anyhow, so Doom 3, fantastic. Running at 60 FPS, amazing. So basically the takeaway here is not that WebAssembly is going to be like the thing you want to jump onto right now. It's more like this is a state-of-the-art capability. A lot of companies, especially large companies, are shipping really rich, interesting content using this technology. This technology allows you to ship code to the web that either already exists, or the JavaScript can't run efficiently enough, or if for some reason you already have a team that's like writing in some other language. And at the moment, there are runtimes for WebAssembly. So like Rust, C++, and C are like pretty much native support. Golang has a reasonable experience shipping with like compiling to WebAssembly using something called TinyGo. So it's like a subset of Go that is well behaved. Python has a lot of, like the Python community has a lot of interest, but its state is very up in the air right now. Like its current solution is kind of crappy. So this is kind of like the reason for why Rust is sort of like an attractive target here. There is plenty of learning materials. Like this stuff isn't rocket science. Like you can ship really awesome stuff to web and people do. So for some reason, this is like something was piquing your interest. Maybe you're interested in like shipping kind of like artsy or like more visual things to the web. Maybe you're curious about extending web applications with ML things that are client side as opposed to having to like poke APIs that are commercial and paid. Like maybe you are trying to push the envelope a little bit in that direction. I think this is this is a very promising technology, and I think it's pretty easy to get into it. And yeah, you can play Doom 3 in the browser. That's kind of cool. That's it. I can try to answer questions. Or I can just play some more Doom, I don't know. Let's see, resume. I've never actually played this game, so if anybody knows, like, it doesn't run super well, but it does run, which is, I guess, cool enough.
Yeah.
Yeah.
Ooh, 60.
Yeah, it's
You just look in a dark corner and it's
yeah,
we can get over to 100.
yeah. It's I mean it
Look
run.
at the wall.
Yeah, just look at this. But yeah, this is a browser tab. Like, what do you expect from a browser tab? Like, is this what you expect?
I want more.
Yeah, I want more. I want big experiences. Anyway, I have like a bunch of links and a bunch of things you can post in the Discord in terms of like things I showed off over here, or just like learning resources or whatever. If folks are curious about this stuff, this is something I want to dive into more myself. So if you're like excited to go on an adventure with somebody who doesn't know what he's talking about, hooray you. Yeah, WebAssembly and Rust.
So question. So, is Rust doing the compiling to WebAssembly, or like what? Okay, so what is
What's
all
the
this
process
pieces?
here? What does the pipeline
Yeah.
look like? You write Rust or whatever language. That language has a compiler, and one of the things the compiler does is like output crap. And the output is WebAssembly bytecode, namely something that a WebAssembly runtime can run.
Okay, so it could be anything, but it can compile to WebAssembly.
Yeah.
Okay.
Yep. So like in the case of Rust, like with many compilers, you specify what you're compiling to.
Okay.
So like one of the previous options was like, am I compiling for ARM or x86?
Okay, gotcha.
And this is like non-compiling for WebAssembly.
I see. Okay.
Interestingly enough, there's a bunch of, this technology has been around for a few years now, and there's a bunch of existing companies that are building runtimes that run WebAssembly payloads for things that aren't browsers. So you can run WebAssembly server-side. This is what Cloudflare workers are. They're like isolated WebAssembly, like that's the reason why you get so little API with Cloudflare workers, because they're not really running Node. They're running this like very small, very reduced sandboxed version of Node in WebAssembly. You end up with Rust containers in Docker, because those containers are like 1/10 the size and much easier to run. You end up with like application server-side WebAssembly runtimes provided by companies like Wasmer and WasmTime and Wasm whatever. So there's like a ton of existing commercial interest here to like basically use this technology as a portable binary format to run expensive, heavy things quickly in a bunch of different places.
I don't see. I'm sure there's a huge crowd of hands
Yeah,
raised back
well,
behind me. Okay, so once you do compile it to WASM,
Yep.
do you then have to trigger from JS, or is it just like that is it? You just boom, it's ready to go, and you just run it.
Yeah. So like the WASM runtime is built into the browser. Like
Okay.
you can load the WASM module. I mean, you still have to like tell something to load the WASM module.
Yeah.
Like that stuff is triggered from JS, which is
Okay.
kind of the similarity to like web worker sort of APIs,
Yeah.
where like you spawn a runtime, and actually I think I had like a little, sorry, it captured the cursor. I need both hands to free myself. If we look at down here, right? Like here, like we compiled this like super minimal module. It created a WASM file. There's like literally a .wasm sitting somewhere that includes things like bindings to the browser, like what it means to be called, that sort of stuff. And then from JS, you create basically an instance of a runtime, which is just like an API metaphor. There's not anything being created. It just like kind of like gives you a handle to like request resources to load. and then you like run the module by sending data to it and getting data back from it. Like in that sense, maybe it's a little bit analogous to things like programming in the GPU, where like ultimately the GPU doesn't know anything about the monitor.
Mm-hmm.
You're just like shoving data through a pipe, and it's doing a lot of expensive computation and shoving data back through the pipe at you. And then you like put in a monitor, like a game or something. Here you have basically some region of shared memory where the browser or whatever like puts some data there for WASM to discover it. The WASM runtime does something with that data, like rendering in the game or build a UI or something like that. It puts the data back in the shared location in memory, and you read from that. That's like what this is facilitating from you.
Gotcha. So you eventually still have to, like, for example, like in the Doom case, you still have to pull that out of the shared memory and like do something with it. Like,
yep. And there's like glue libraries to do that. Like the browser, like this is a well-trodden path. This isn't something like, the entire point is to like create a toolbox so that you as the application developer don't have to build an entire pipeline from end to end. Like all you really have to do is like get your code compiled into this kind of like file, and then load this file in the browser, like from a JavaScript command or something.
Gotcha. Okay.
Easy questions.
So, am I to understand, like, there's a WASM machine, there's a WASM machine running on my computer. Does the WASM machine have a notion of multiple threads so that I could run multiple programs on the WASM machine simultaneously?
Yes.
Oh, cool.
Like the WASM runtime is multi-threaded. That's one of the benefits. Like that's actually one of the foundational reasons where it's like, okay, JavaScript runtimes have certain conventional restrictions on them. So here is basically a pool of compute resources that you can just like dump work into. And what that work looks like is kind of up to the application. It's just kind of like an extra CPU running in your browser, kind of.
It doesn't look like it has too much of a learning curve from JSX. It looked a little bit messier, but it's still very.
I mean, it has peculiarities. Like it's kind of like jumping frameworks, where it's like, at some point you're like, well, I already know React or whatever. Like, why am I writing it this way? And you might be writing it this way, like either because you have pre-existing interests in like the language, the ecosystem, or because you do expect to run something that's like richer and more demanding. Like there are trade-offs here. If you're like literally just like porting your React application to this new model, like it'll have a different performance profile. Like it's more data to load, but it runs faster, kind of sort of thing. Like the tooling for Rust in the browser is like it's not ahead of where the JavaScript thing is. It's kind of just like emulating JavaScript experience. So you don't get things like file chunk screening or something like that, where like people talk about like, oh, I'm gonna do like code splitting. I'm gonna like ship JS to the browser incrementally. Like you don't get that so far, but like all this stuff is catching up really, really fast.
So is WASM well supported in all the browsers and like?
As of recently, yes.
Like what you can expect your clients will be able to. Like,
yes.
Because you don't want to like.
Yes, Safari was the holdout. It's like at this point it's pretty much mostly caught up. Like the support for it is pretty recent, but by now all the evergreen browsers have it.
Oh, cool.
Yeah, it's 95% global support.
Nice. So this is the future, I guess.
This is that's the entire point where it's like, this isn't necessarily like fun to write on its own. Like I'm not saying like you're gonna be going yay all the time. There are obviously like rough edges and you have to like, there is a learning curve and like an on-ramp. But for certain things you can't do in the browser except this way, like this is the only way to do it.
Oh, okay. Let me ask you this. Would you say the biggest implementation at this point is for existing code bases, I want to run that said code base in the browser? Or would you say, I mean currently, obviously futures, or would you say it's more for Greenfield, I know this is going to be complicated, like a Figma, where this is brand new, I want to do something that's a bit of...
Like Figma were like one of the big drivers behind this initiative in the first place, because this is like what they wanted to ship and they had no other way of shipping it.
Yeah.
So like a lot of the players that have shipped really big applications this way have had contributions into like what the standard looks like, and like what does the runtime support, like what are the requirements to be a compliant WASM runtime, so that Figma could ship the Figma client, or like Google could ship Google Earth, or Adobe could ship its Photoshop thing. Where I see this stuff being like most accessible for individual developers, I think is probably ML stuff. just because there's a ton of interest and because that stuff is usually really heavy, and there's also interest in making it more localized. Where like instead of paying for APIs, I can run some kind of like smaller model on my local hardware in a way that's, you know, less custom, like where you have to do less custom work. Where you can just say, okay, fine, the browser is now my server, and the browser runs the model, and I just like look at the output or whatever. Because that is particularly an example of the kinds of things WASM was built for, namely heavy computational workloads that don't necessarily have to involve like directly dragging in the browser. Like you offload work to WASM, and then you get answers back out of it.
Kind of related question. It sounds like it can't reach out very far. Like it has its own internal thing. What does it have access to?
Yep. By default, nothing. That's the entire purpose.
Okay.
Like the earlier, like some of the discontent with the earlier like browser plugin stuff, like ActiveX or whatever, was that it was poorly sandboxed, and it had like this constant stream of security loopholes.
Yeah.
Like hence Steve Jobs' like famous anti-flash screed and whatever.
Yeah.
So the default capability is basically nothing. It's just a compute engine. You extend that using something called WebAssembly System Interface by adding capabilities that are themselves like closely guarded. So like file system access, or like other device access, or network access, or there's a number of WASM modules basically. So you specify, okay, this application, like this WASM instance will have the following kinds of access, and you can like monitor what it's doing. So in that sense, it's not like there's no real inherent limitation to what you can do with it. Like clearly here we're rendering to a browser. Like WASM is just like painting directly to the DOM. But that's not a default capability, it's something you have to turn on. As opposed to, okay, here's a Flash player, it runs on your page and it does whatever the hell it wants. You're like, you have no idea what it's doing. This by comparison is granular and monitorable.
Super informative.
Woo! Excellent.
Awesome.
Well, I'll dump some links into the thing and folks can play around with stuff.
And I know you got a party to get to, but are you going to be able to stick around and have a breakout group around this?
Absolutely.
Because I think that would be an awesome if people have additional questions.
Yeah, I want to eat that ice cream. That's
Yeah, that's
what
actually
I'm-
the real reason.
That's
you're
what I'm here for.